Hello, welcome. Thank you for joining our video about IEC61850 protocol on WCCLite and whatever applications we are currently testing. But before we begin, do let us know about your own applications for this protocol. Maybe you can already imagine where our WCCLite could be used in your projects. If you want to discuss with us and be the first to hear all the latest releases that we are making, do follow us on LinkedIn and subscribe to us on YouTube channel. What we have noticed is that IEC61850 protocol can be beneficial not only for automating secondary substations, reclosers. This state-of-the-art protocol, so prevailing nowadays in the energy sector, can actually be found in wind power farms, electric charging infrastructure, distributed generation. Do you belong to any of those spheres? What we have done here at Elseta is that we implemented IEC61850 Client and Server support that matches IEC61850 MMS protocol suite. Where can it be applied? For IEC61850 Client, we gather data from various IEC61850 devices like voltage regulators, protective relays, reactive power compensators, and many other devices already working with IEC61850. Basically, we gather data from IEC61850 devices, store it internally in R2, and transmit data to SCADA DMS systems. We also enable to execute commands from SCADA DMS. For IEC61850 server, we see further applications. There, we gather data from various field devices running on whatever protocol they are using, and then sending this data via WCCLite to a higher level R2 via IEC61850. Imagine a well-designed project with protective relays that cannot use IEC61850 protocol. It is a good project, but you need to upgrade it to IEC61850. What can you do? Take the WCCLite device to collect protective relays over IEC 103, Modbus, DNP3, and then send this data to a higher level R2 via WCCLite, via 61850. So basically, this small device packs inside not only many R2 functions, but also VPN, firewall, cybersecurity features. But to get information on all of this, let's go talk with our developers in R&D. So, here we have Matas and Arturas, our R&D developers. So, great to visit with you. Okay, Arturas, can you tell us a bit more about 61850 Client? What are its possibilities?
The possibilities are quite broad. As we all know, applications for 61850 are steadily rising, and the protocol is used quite extensively. One can use it in relay protection, in wind or solar power inverters, generators, and other various equipment. So WCCLite can interface a lot of data servers for us. We can acquire the data and later convert it to other protocols, such as IEC104 to send it to remote SCADAs, or we can send the data via APIs to some remote clouds.
So now that we have this overview, maybe you can tell us about this setup that we have here. What is connected here?
The setup is quite simple. We have WCCLite connected to the relay, which is here. the Siemens relay. We are connected to it via Ethernet. We are not using any TLS, no transport layer security. We are getting the data via report control blocks, and we might be able to send commands to either close the circuit or open the circuit.
Okay. And how do you configure for such an application?
There are several things you have to do first. At first, you have to configure the relay and get the SCD file, which contains all the configuration that whole of substation requires. That includes both server side and client side. This relay can handle one client. So WCCLite is one of the clients, like the only client. Later we fill in configuration in Excel and upload Excel configuration to the device. And that's pretty much it. If you are using transport layer security, you should also upload certificates before using the relay or other server device. But for TCP connection, that's pretty much it.
Okay, Artūras, can you give me a quick overview of how the configuration is done then?
To configure any device, basically to run with WCCLite, we use Excel configuration. And configuration for IEC61850 is basically done in the same way, just using different columns for it. And we have two tabs, basically, one for devices and one for signals that are for these devices. And you have to do basically the same for IEC61850. As you can see, I have added TCP client for IEC61850 and filled in some columns to get it running. I have connected relay to address which you can see in the screen, and I have used default port, which is 102nd, and that is not all. You can also fill in TLS, transport layer security data, in columns called TLS local certificates, TLS peer certificate, and TLS private key. And what is needed more to run, what the parts that are mandatory to get the device running are IED name, which basically names whole of the substation, which names the intelligent electronic device as such, kind of a whole substation. And you can optionally use authorization and originator, which can be used while sending commands. Well, that's the devices part. To configure signals, there are quite some columns to be filled. As we know, 61850 uses report control blocks to get the data from server. So all of the parameters have to be filled in here. So there are quite a lot of them. I will run through them bit by bit. I will not go through in much of the detail, but basically you have to fill in the data which is describing datasets and report control blocks that are attached to it.
Okay, so this is more or less it for this quick application that we have here of connecting IEC client to Siemens relay, yes?
Yes, yes.
Okay, thank you, Artūras.
Thank you.
Matas, good to be back with you now. So can you let us know a bit about IEC61850 server? What are its possibilities?
Its possibilities are quite broad. It can be used for data acquisition from other devices like Modbus, which have Modbus slave or 104 slave. It can be used in AC/DC panels, like collect data from energy meters, from I/Os modules, from circuit breakers. Also, it can be used in the bay unit to collect data, and to retrofit relays which do not have 61850 in its supported features list.
Mm-hmm.
Yeah.
Okay, and do you have some setup to show for us today?
Yeah, I have a WCCLite, of course, acting as a server, and I'm using ED Scout as a client to simulate a client.
So can you then show us how this configuration is done and run us step by step?
To configure 61850 server, the process is quite similar to the client, but you need to upload the data model that is made from CID file. CID file can be, you can use your own CID file, or we can provide some examples. Yeah, so the server is quite universal from this point of view, because there are no static models. Other vendors use static models, and you cannot have, for example, more double point signals than there is in the model. In our configuration, you can configure the count of them as much as you want. Yeah. The first step is to convert the IEC61850 data model from ICD or CID file to our format, which is CFG. You are converting the file. The file can be uploaded to WCCLite via its web interface. Here. Now the model file is uploaded. As you can see, there's a file name here. You can download it as well. The next step is to configure the IEC61850 server device in Excel. It's quite similar configuration as the client. It also supports the TLS feature, also supports password authentication, and as well it supports allowed IP list. So it's quite important cybersecurity feature, because any IP that isn't in the list cannot connect to this server.
That's good to hear. Okay.
Yeah, the additional fields that you must fill in, it's model file name. It's the model that you have uploaded to VCC in previous step. 61850 server has some good feature that the signals can be isolated between SCADAs and can be routed one signal can be routed to one SCADA and the other to another SCADA, and these SCADAs won't see any other signals. The other step is to configure signals. The process is quite identical to the client one, and to upload this Excel configuration, you can use our Excel utility. You are converting it to our internal format and uploading it to the device.
What will we do next?
After the Excel configuration template is uploaded, we can start to collect data. I will use Vinci Protocol Analyzer as the Modbus slave device, and I will use EED Scout as a client for the 61850 server. So as you can see, the three signals, two single points, and one measurement is live. If I stop the Modbus, the qualities will be questionable. After I start Modbus once again, the qualities are good. I can change the value to, for example, 28, and EED Scout will be change its value to 28. Important feature to note that WCCLite supports edition 1, edition 2, and edition 2.1 modes in IEC61850 server. We can also launch a debug mode for the 61850 server, and if there's some error, we can see it in the screen. For example, if it's incorrect password, so it will write you that the password is incorrect. In terminal screen, you will see all the events, and I will connect the Scout, and you can see that client is connected. So you can see all the data flow, all the errors here.
So now we made sure that everything is also up and running.
Yes.
So that's also it for this application that we test.
You can also check the signals in the WCCLite web. There's a tab called Imported Signals. There you can also see values that are retrieved from Modbus. It's the same 28, and same for those binary values. Yeah, so that's pretty much it.
So Matas, Arturas, thank you very much for giving us all this explanation. And basically this is it, what we had prepared for you today. What is true is that all of your feedback and your likes are what makes us sure that the topic is relevant and encourages us to create more content for you. So please follow us on LinkedIn, subscribe to us on YouTube channel, and also let us know about any further topics you might find interesting and relevant. So we might address them in our future content. But for now, stay tuned, follow us, and do let us know in case you have any questions, any feedback. I am Ugne, I'm the sales manager at Elseta, and so I'll be happy to address anything that you have to tell us. So have a good day, stay safe and stay well.